Okay, so we are now doing task 3.2, half interested. Just as a reminder, these videos are meant to help and to support, but the expectation is still that you're going through and you're trying your best to answer these on your own. And if you get stuck, if you need a little bit of an explanation as to where to go, then you can watch the videos. But it really should be you trying to make sense. The other thing too is that even though I'm presenting the answers and the thought process, you need to make it your own. You need to be able to say it in your own words, in your own thoughts, and you need to internalize the math that's being represented. Okay, so without further ado, let's get started. This task is called half interested. It's a solidify understanding task because it's building on task 3.1. It's solidifying the idea that we were talking about there. So it says Carlos and Clarita, the Martinez twins, have run a summer business every year for the past 5 years. Their first business, a neighborhood lemonade stand, earned a small profit that their father insisted they deposit in a savings account at the local bank. When the Martinez family moved a few months later, the twins decided to leave the money in the bank where it has been earning 5% interest annually. Okay, this is going to be important for later. Carlos was reminded of the money when he found the annual bank statement they had received in the mail. Remember how Dad said we could withdraw this money from the bank when we are 20 years old? Carlos said to Clarita. We have $382.88 in the account now. I wonder how much that will be 5 years from now. Given the facts listed above, how can the twins figure out how much the account will be worth 5 years from now when they are 20 years old? Describe your strategy and calculate the account balance. So your strategy may vary, okay? You might have different strategies. So I highly recommend you pause the video, try it for yourself, see if you can figure out a strategy for determining how much money would be in the bank. And then coming back and seeing the strategy here. Okay, so the strategy would be that they take the amount that they have now. So let's say, we'll do as an example, let's say we take $382.88. Okay, they're going to take 5% of this because that's how much money they're earning. They're earning 5% annually. So let's find out what 5% is. Okay, 5% of that, and then we're going to take whatever that is and we're going to add it back to the amount that we have. Okay, and when we do this, we're going to get $402.02. Okay, and then you can repeat this process again over and over again. So that leads us to number 2. Carlos calculates the value of the account 1 year at a time, which is kind of what we just did. We just went from 1 year to the next year. He has just finished calculating the value of the account for the first 4 years. So here's the value for the first 4 years. Describe how he can find the next year's balance and record that value in the table. So what he can do is he can do $465.39, find 5% of that, and then add it back to $465.39. Okay, and if he does that, let me just get my calculator out here. If he does that, $465.39. Okay, that's going to equal $488, and I'm going to go ahead and round here, and 66 cents. I'm rounding up. So we can fill this in, $488.66. So it says describe how he can find the next year's balance. We're going to go ahead and write that in English. Take the current balance, take 5%, take 5% of the current balance and add it to the current balance. Okay, now it gets a little bit more complicated. So number 3 says Clarita thinks Carlos is silly calculating the value of the account 1 year at a time. and says that he could have written a formula for the nth year and then evaluated his formula when n equals 5. Write Clarita's formula for the nth year and use it to find the account balance at the end of year 5. There's a couple of different ways to do this. Okay, I invite you to find the formula, to try it, and then come back once you think you know, and I'll show you one strategy to find it. Okay, so the strategy to find it that I found was you can figure out, since it's 5% interest, you can see if you can find a common growth value here. Okay, see if there's either a common factor or a common, just something in common that leads from one step to the next to the next. And what you'll notice is that there is a common factor, and you can multiply by 1.05. Okay, now there's a reason for this, and if you want to go into a deeper explanation as to why it's 1.05, show it to your teacher, and what they'll do, they can probably show you how to even go from something like this into understanding where the 1.05 comes from and stuff like that. So the formula then that we can do is 382.88. And students, this is multiplying by 1.05 repeatedly. So what we're going to do is we're going to take the amount, we're going to call it f of n because it's asking us for the nth year. We're going to take this amount and we're going to multiply it times 1.05 n times. So in other words, at year 0, we're not going to use this at all, right? It's like we're not even going to use it. But at year 1, we're going to multiply it once, so it makes sense for the exponent to be 1. At year 2, we're going to do 382.88 times 1.05, and then times 1.05 again, and that's how we're going to land on year 2. So the n is the year, and it tells you how many times to multiply by 1.05. So here's our formula. You want to make sure that you understand how this formula came about. Okay, take your time, ask questions to your teacher. How does this formula make sense? Internalize it, make it your own. Okay, let's keep going. It says, so question 4, Carlos was surprised that Clarita's formula gave the same account balance as his year-by-year strategy. Explain in a way that would convince Carlos why this is so. Okay, so this is going to connect Carlos and Clarita's strategies. Okay, now Carlos's strategy is to take the current amount and multiply it by 0.05, okay, and then add it back to the current amount. Now, if we made a label for current amount, let's call it A for amount, that would be saying A times 0.05 plus A, right? The current amount, the current amount. A stands for current amount. Now from here, what we can do is we can factor out A. We can factor A out and get 0.05 plus 1. Okay, so that's factored. And then we can multiply, or we can add this, and that's going to give us A times 1.05. And that is how we got to the 1.05. So instead of taking the current amount, taking 5% of it, and then adding it back, it's the same to do taking the current amount and multiplied by 1.05. Okay, these two are functionally the same. They give you the same, they're mathematically equivalent. They give you the same answer. So this is equal to A times 1.05. So this, if you explain to Carlos, hey, Carlos, this is your strategy, but this is Clarita's strategy, and look how they're the same, because all you have to do is factor it out, that would probably convince Carlos. Okay. Let's keep going. I can't remember how much money we earned that summer, said Carlos. I wonder if we can figure out how much we deposited in the account 5 years ago, knowing the account balance now. Carlos continued to use his strategy to extend his table year by year back 5 years. Explain what you think Carlos is doing to find his table values 1 year at a time, and continue filling in the table until you get to -5, which Carlos uses to represent 5 years ago. So if we were multiplying by 1.05, what we can do is we can divide by 1.05, right? So we can take this because that's going backwards. Going forwards is multiplying, going backwards is dividing. So we can go 364 divided by 1.05, and that's going to give us 346.67 divided by 1.05. That's going to give us 330.16 divided by 1.05. We get 314.44 and divide by 1.05. We get 299.46. Okay, and that's dividing by 1.05 over and over and over again. Okay, so it says, explain what you think Carlos is doing to find his table values 1 year at a time and continue feeling. So Carlos is dividing by 1.05 to go backwards. Since he multiplied to go forward. Okay, then it says Clarita evaluated her formula for n equals -5. Again, Carlos is surprised they get the same results. Explain why Clarita's method works. So what Clarita is doing is she's taking her formula. Remember, we wrote it before. F of n equals 382.88 times 1.05 to the n. And she plugged in -5 for n. So she got f of -5 equals 382.88 times 1.05 to the -5 power. Now, remember, a negative power is the same as dividing. So what Clarita's method is actually doing is it's dividing by 1.05 5 times. So a negative exponent is representing division, representing more than one division, potentially, more than one division, potentially. Right? So Carlos is over here dividing one at a time, and Clarita can do the same thing a lot faster just by putting a -5 in the exponent. So instead of dividing by 5 times, one at a time, you can just divide by 5 or divide by this 5 times just with a -5 exponent. Clarita doesn't think leaving the money in the bank for another 5 years is such a great idea and suggests that they invest the money in their next summer business, Curbside Rivalry, which for now they are keeping top secret from everyone, including their friends. We'll have some startup costs and this will pay for them without having to withdraw money from our other accounts. Okay, so that doesn't tell us what, or doesn't ask us to do anything. Let's keep going. Carlos remarked, but we'll be withdrawing our money halfway through the year. Do you think we'll lose out on this year's interest? No, they'll pay us a half portion of our interest, a half-year portion of our interest, replied Clarita. But how much will that be? Asked Carlos. Calculate the account balance and how much interest you think Carlos and Clarita should be paid if they withdraw their money half a year from now. Remember that they currently have this much money in the account and they earn 5% annually. Describe your strategy. This is for you. Okay, this is for you to think about what happens. They get 5% total at the end of the year. Okay, but what if they don't go the whole year? Then they're not going to get 5%. They're going to get less, right? How much do they get? Do they get 2.5%? Do they get something else? Okay, think about it and ask your teacher, talk about it with your other students that are working on this together. And then we'll come back once you've talked about it and once you have an idea. Let's keep going. Carlos used the following strategy. He calculated how much interest they should be paid for a full year, found half of that, and added that amount to the current account balance. Clarita used this strategy. She substituted 1/2 for the n in her formula. This is a typo. It should have a 3. 382 times 1.05 to the n power and recorded this as the account balance. This time, Carlos and Clarita didn't get the same result. Whose method do you agree with and why? So again, you read the two strategies, right? One of them might be correct, but they can't both be correct because it's the same, they got different answers. So whose method do you agree with? Again, this is your opinion, your thoughts. What do you think? Come up with an opinion, pause the video, come up with an opinion, and then come back once you have an idea. Okay. Clarita is trying to convince Carlos that her method is correct. Exponential rules are multiplicative, not additive. Look at your table. We will earn $82.51 in interest during the next 4 years. If your method works, we should be able to take half of that amount, add it to the amount we have now, and get the account balance we should have in 2 years, but it isn't the same. Carry out the computations that Clarita suggested and compare the result for the year 2 using this strategy, as opposed to the strategy Carlos originally used to fill out the table. So what Clarita is saying is to go back to over here, right? And she says in the next 4 years, this amount, right, to go from here to here, they will have made $82.51 from year 0 to year 4. Okay, and what she's saying is that if Carlos's strategy works, you take half of this, right? So 82.51, right? You take half of that, and you're going to get 41.265. No, 255. Excuse me. Okay, that's half of the money that they would have made, and you could just add this to the original, and that will take you to there. So let's see what happens when we take. What happens when we take $388 or $382.88 and add $41.25 to, well, let's add this and round after. So if we add those together, let me just pull out my calculator here. Add those together, we get 382.88 plus 41.255. We get 424.135. Okay, and if you round this to the nearest cent, it would be 424.14. Okay, so that's if this strategy worked, this would be correct. But look, $422.12. So this is off by about $2.02. It's actually more. Okay, think about why that might be. Why is it more to do it this way? Right, because Carlos originally was multiplying each year by 1.05. And what he's doing here is he's taking an addition, which is not a multiplication. He's taking an addition, and he's applying half of an addition, which is not the same answer that he got before. So it says the points from Carlos's table, see question 2, have been plotted on the graph at the end of the task, along with Clarita's function. Plot the value you calculated in question 9 on this same graph. What does the graph reveal about the differences in Carlos's two strategies? Okay, so let's look at the graph. All right. This solid line right here, this solid amount, or this solid line represents the function. That's Clarita's function. And you can tell ever so slightly there's a little curve to it. It's curving a little bit. It's not perfectly straight. And then on these dots are Carlos's actual values, which you can see they line up with Clarita's function, right? And that makes sense because that was the whole thing, was that Carlos's plan was originally working with Clarita's function. They were getting the same values. Now it asks us to plot this value. So this incorrect value, 424.14, is what would happen if we took half the growth and just applied it. So that's in year 2. And 424.14 is right, it's like right here, right? It's not quite 425. And notice how it's on this dash line. We're going to come back to that later, but this is 2, 424.14. That's what that is right there. Okay, so what does the graph reveal about the differences in Carlos' two strategies? They're not precisely the same. And if you want to go into a little bit more detail, one of them is curving and one of them is not. One is curving, the other is not. Okay. It says now plot Clarita and Carlos values for half a year, see question 8, on this same graph. Okay, so we have to go back to question 8 and actually calculate. So let's plug in to this. Let's do Clarita's first because we can plug that into a calculator very quickly. So we get 382.88 to the power of 1.05. No, excuse me, not to the power of, times 1.05 to the power of a half. And this is what that looks like on a calculator. Just like that. So I can press equals. And this is Clarita's strategy. 392.3, we can round that to 4 nearest cent. So this is 392.34. Okay, that's Clarita's strategy. And then Carlos's strategy was to calculate how much would be paid in a full year. So let's see how much they would have been paid in this year. We want to subtract this first. $402.02 minus $382.88. And we can find that in our calculator as well. 402.02 minus 382.88. Okay, and that looks like this on the calculator. Sorry about that. You get 19.14. Okay, so this is how much they would have been paid in the full year. And so if we take half of this, that's going to be $9.57. That's half. So if we apply, if instead we apply half of it to 382.88, and that 382.88 plus $9.57. 9.7 plus 382.88. That's going to give us 392.45. Okay, now these numbers are very close together, but Carlos's strategy is giving more. It's giving more, right? Ever so slightly more. So why is that, right? How come Carlos keeps getting more? They're both around 392.34. So that's about, let's see, this is 1 year. So we need half of this, which is 1, 2, 3, 4, 5. About 2. This would be like half a year. And that would be here and here. So they're pretty close. They're like right on, they're almost on top of each other. They're so close together. Okay, it says, your data point seems to fit the shape of the graph better than mine, Carlos conceded. But I don't understand how we can use half as an exponent. How does that find the correct factor we need to multiply by? In your formula, writing 1.05 to the 5th power means multiplying by 1.055 times. And writing 1.05 to the negative 5th power means divide by 1.055 times. But what does it mean when you do 1.05 to the 1/2 power? Clarita wasn't quite sure how to answer Carlos' question, but she had some questions of her own. She decided to jot them down, including Carlos' question. Answer each of Clarita's questions listed above as best as you can. And this is for you to answer, okay? This is up to you. Make sure that you check with your teacher and try to answer it as best as you can using your own ideas. And this is going to help you to internalize what is going on. Okay, so we're going to go on to the ready, set, goes now. Or actually, we still have one more. Sorry. As Carlos is reflecting on this work, Clarita notices the date on the bank statement that started this whole conversation. This bank statement is 3 months old, she exclaims. That means the bank will owe us 3/4 of a year's interest. So how much interest will the bank owe us then? Asked Carlos. Find as many ways as you can to answer Carlos' question. How much will their account be worth in 3/4 of a year if it earns 5% annually and is currently worth $382.88? Okay, that one is also up to you. Okay. Find as many ways as you can to answer this question. What if it's 3/4 of a year? Okay. Again, and this is going to help you to internalize the idea that the book is trying to teach you. Okay, let's go to the ready, set, goes. I'm going to provide you with some answers here, and you can ask questions about them to your teacher when you have some time and when your teacher has some time. Simplify each of the radicals. So the square root of 40 is going to be, we can simplify this into 16 times 5. No, that's wrong. 8 times 5. Let's do this one better. Let's do the square root of 4 times 10. This is live, everyone, so I have not rehearsed this. So square root of 4 times 10, and we can take the square root of 4, but we can't take the square root of 10. 10 doesn't have an integer square root. So if we take the square root of 4, we get 2, and the 10 doesn't have a square root, so it's just going to stay. Okay, and that's our response here. So the idea is when you get one of these, you want to separate the number inside using multiplication and into numbers that have square roots. So for example, 50 has a square root of 25 times 2. Right? So 50 is 25 times 2. And we like that because the square root of 25 is, well, it's 5. So we can say this is 5√2. Okay, now over here, we have a different index. Okay, so this one has a little 3. I don't know if you can see that, but there's a little 3 right there. This one, these ones didn't have any, so they're just square roots. You're just looking for numbers times themselves. On this one, you're looking for a number times itself 3 times in here. So I find sometimes when the index is higher to just completely factor, or we call it prime factorization of the 16, which is 2 times 2 times 2 times 2. So that would be 16, right? 2 times 2 times 2 times 2. Now, because the index is 3, we can take this, which is 8. Okay, and then we can actually answer this question. So the question is, what number times itself 3 times equals 8? And the answer is 2. So because we had 3 2's, that can then we can then pull that out. And this last 2 is going to stay in there. And we keep the index of 3 on the radical there. So that's 2 times the cube root, or you could say the third root of 2. Okay, square root of 72. Let me put a box around these. So the square root of 72. 72 is 36 times 2. So that will be 6√2 as our answer. And this is the 4th root. There's a little 4 in there, so we need to break this down until we find 4 of the same number. So that would be 3 times 3 times 3 times 3. That'll give us 9 times 9, which is 81. And so because there's 4 3's in there and we have an index of 4, we can just resolve this, and that's just 3. Okay, square root of 32. Okay, so 32 is 16 times 2. 16 is 4 times 4, so we can just say this is 4√2. Okay, here we've got the 5th root. There's a 5 in there, so we need to break up this 160. We can do like 2 times 80, and then we can break up the 80. 2 times 2 times 40, we can break up the 40. 2 times 2 times 2 times 20, break up the 20. 2 times 2 times 2 times 2 times 2 times 10. So that this will give us 20, 40, wait, hold on, 20, 40, 80. This is wrong. it should be times 10 here. Okay, I messed that one up. Times 10. And then we can break up the 10. 2 times 2 times 2 times 2 times 2 times 5. Okay, so we have got 10, 20, 40, 80, 160. Okay, that's right. And there are 5 2's in there. And this is a 5th root. The index is 5, so we can pull out the 2. These should all be 5's. You can pull out the 2, the index of 5, and it's 2 and the 5th root of 5. This is the answer here. 2 times the 5th root of 5. Okay, square root of 45, we can write this as 9 times 5, and the square root of 9 is 3. So we get 3 root 5. And here we've got the cube root, or the 3rd root of 54. So we need to break up 54. That can be 2 times 27. 3rd root of 2 times 27. 27 is 3 times 9, so we can try that. Cube root 2 times 3 times 9. 9 is 3 times 3, and that's going to give us 3 3's. 2 times 3 times 3 times 3. Here's our 3 3's, so we can write this as 3 and the cube root of 2. And that is the answer to number 9. Okay, let's keep going. Okay. Number 10. See, you may have found the arithmetic and geometric means in your prior work. Finding arithmetic and geometric means requires finding values of a sequence between given values from non-consecutive terms. In each of the sequence below, determine the means and show how you found them. Okay, so this says find the arithmetic mean, which means we're operating under the assumption that each increase is an addition or a subtraction and that they're all the same. So in other words, from 5 to 11 is plus 6, and we care that it's plus because it's arithmetic, so plus 6, which means this is going to be plus 3, and that's going to be plus 3 because this is plus 6. So 5 plus 3 is going to be 8, and then 8 plus 3 is 11. So that's how you find the arithmetic mean. Okay, let's see. From 18 to negative 10, we are subtracting, and that's subtracting 28. So we're taking that and we're separating it into 1, 2, 3, 4 jumps. Negative 28 divided into 4 jumps is going to be negative 7. Negative 7, negative 7, negative 7, right? Subtracting 7 each time. 18 minus 7 is 11. 11 minus 7 is 4. 4 minus 7 is negative 3. And negative 3 minus 7 is negative 10. So there you go. Number 12. So from 12, we're jumping all the way to negative 6. This jump is subtracting 18. And we're separating that into 1, 2, 3, 4, 5, 6 jumps. So negative 18 separated into 6 separate jumps is going to be minus 3 for each jump. So 12 minus 3 is 9. 9 minus 3 is 6. 6 minus 3 is 3. 3 minus 3 is 0. 0 minus 3 is negative 3. And negative 3 minus 3 is negative 6. So that's the arithmetic mean. It's always working with addition or subtraction. Okay, let's look at number 13. It says find the geometric mean for the following and show your work. So geometric mean means we're operating under the assumption that all of these are multiplications. So 3 times something equals 12. Okay, this is going to be 3 times 4. So we could say times 4 is the same as times 2 times 2. So this will be 3 times 2, which is 6. 6 times 2 is 12. Okay, and then that gives us a geometric sequence. Okay, let's see. We need 3 jumps. 7 times something gives us 875. This is where we can pull out a calculator. So we can go 875 divided by 7 is 125. Okay. So that means from here to here, you're multiplying by 125. That means each of these needs to be multiplied by 5. So this could be 35. 35 times 5 is 150 plus 25, 175. And then 175 times 5 is 875. So these are all multiplying by 5s. Okay, and then down here from 4 to 972, right? This jump here, we can go on our calculator. 972 divided by 4 is 243. And we need to break that up into 1, 2, 3, 4, 5 jumps. So what number times itself 5 times equals 243? And this is where we can off to the side. What we're looking for is we're looking for the 5th root of 243. So let's break down 243. If we break that down, that's going to be 3 times 3 times 3 times 3 times 3, which is 53. So actually, these are all going to be times 3. So 4 times 3 is 12. 12 times 3 is 36. 36 times 3 is 108. 108 times 3 is 324. And 324 times 3 is 972. Okay. Number 16, fill in the tables of the values and find the factor used to move between whole number values, FW, as well as the factor FC used to move between each column of the table. So these big jumps represent the FWs, and then these little jumps represent the FCs. So to go from 4 to 16, you're multiplying, it says factor, which means multiplication. From 4 to 16, you're multiplying by 4. So FW must be 4. And if that's true, and you're breaking that up into 2, then that means that these have to be the square root of 4, which would be times 2. So this would be 8. Doubled, 16 doubled is going to be 32. Double that again, you get 64. And so 16 times 4 does equal 64. So these little ones are times 2s, and these big ones are times 4. Okay, let's look at number 17. Okay, to go from 4 to 8 is a multiplication of 2, which means this one will also be a multiplication of 2. So this will be 16, and FW is going to be 2. And we're taking 2 and we're breaking it into 2 here. So this will be 2 to the 1/2 power, 2 to the 1/2 power, 2 to the 1/2 power, 2 to the 1/2 power. And that's what that's going to be. This will be 4 times 2 to the 1/2 power. This will be 8 times 2 to the 1/2 power. Instead of 2 to the 1/2 power, we could also have used the square root of 2. Right? Because the square root of 2 says what number times itself equals 2? And the answer is this number times itself equals 2. So those two are actually equal to each other. You could have used, instead of using 2 to the 1/2 power, you could have used the square root of 2. Okay, from 5 to 15, that's times 3. So from 15 over here, this is going to be 45. And that means these are going to be, we could say 3 to the 1/2 power, but just to mix things up, let's say square root of 3. So these are 3 and these are square root of 3. So this would be 5 root 3 and this would be 15 root 3. Okay. Again, if you have questions, ask your teacher to explain it. You want to internalize the ideas that are being taught here. It's not just about the answers, it's about understanding what's going on. Okay. And let's wrap it up with a go. So find the desired values for each function below. So in other words, we're going to be plugging in these values. So find f when x is -3. So If x is -3, that's going to be -6. -6 minus 7 is -13. Find when it equals 21. Okay, when does this equal 21? In order for this to equal 21, that means that this has to be 28, because 28 minus 7 would equal 21. If this is 28, then x has to be 14. So let's see if that works. If x is 14, then that gives me 28. 28 minus 7 is 21. Yep, that works. Okay, so that's true. What happens when x is 1/2? So if I put 1/2 here, 2 times 1/2 is just 1. 1 minus 7 is -6. Okay. Now let's go here. What happens when we put -4? That means we're dividing by 3 4 times. So this would be 2 over 3 to the 4th like this. You're dividing by 3 4 times, or you could say 2 divided by 81. Find when g would equal 162. Well, in order for g to equal 162, it has to be multiplied by 2. So that means this part would have to be a number, so that we can multiply that by 2, you get 162. So this has to be 81, because 81 times 2 is 162. And if that's 81, that means x has to equal 4. So x has to equal 4. Okay, and what happens when g is 1/2? Well, 3 to the power of 1/2 is just the same as the square root of 3. So we can write 2 times the square root of 3. There. Okay, 21. Find I of 12. So what happens when we plug in 12? We could put 210 times 1.08 to the 12th power. We could find a decimal approximation for this. So let's find out. 210 times 1.08 to the 12th power. That's going to give us 528.81. Yep. Find when does it equal 420? Well, okay, so in order for this to equal 420, this has to be a number, so that when you multiply it to here, you get 420. So this has to equal 2. So when does this equal 2? Right? When does 1.08 to the t equal 2? That's a good question. You can use logs here, logarithms. Why would they give you this? I'm going to leave this like this. I'm not ready to teach about logs. That's something you learn in Math 3. So that's interesting. Again, I have not practiced this at all ahead of time. So just, that's interesting. Okay, what happens when you raise it to the 1/2 power? And then you just get 210 times the square root of 1.08. Okay. 22. What happens when h equals -5? We get 25 minus 5, which is 20, minus 6 is 14. When does this equal 0? It can equal 0 2 times. You can either plug in -3, or you can plug in 2. If you plug in -3, you get 9 minus 3, which is 6, minus 6 is 0. So x can be -3. Or you can plug in 2, because then you get 4 plus 2 is 6, minus 6 is 0. So you can, either one of these will work to make it 0. So you've got 2 different answers there. And what happens when you plug in 1/2? So when you plug in a half, you get 1/2 squared plus 1/2 minus 6. This is 1/4 plus 1/2 minus 6. That's 3/4 minus 6. So 3/4 minus 6. That's going to be negative 5 1/4. So negative 5.25. Okay. Let's look at 23. What happens when we plug in negative 7? We get 35 here plus 9. 35 plus 9 is going to be 44. When does it equal 0? In order for it to equal 0, we can solve this. When does this equal 0? Right, when does that equal 0? We can subtract 9 from both sides. Divide by negative 5 on both sides. So the negatives cancel. You get 9 over 5. So when x equals 9/5 is when it equals 0. And what happens when we plug in a half? You get negative 5 times a half plus 9. That's going to be negative 5 halves plus 9. We can get a common denominator here. Negative 5 halves plus 18 halves. That's going to be that's going to be 13 halves. Or 6.5 is that one. And then 24, what happens when we plug in negative 2? It means since it's the exponent, you're plugging in negative 2 for x. That means you're dividing by 5 2 times. So this is going to be 2 divided by 25. Okay, when does it equal 1? When does this equal 1? Well, let's find out. So when does this equal 1? In order for this to equal 1, you can divide by 2 on both sides. This has to equal a half. Does this equal a half? Again, this is a logarithm thing. If you want to look up logarithms and how to do this, feel free. But you need to know what x needs to be to make this true so that it can equal 1. What happens when we plug in a half? 5 to the 1/2 power is the square root of 5 times 2 is just 2. Okay, and that is the end of task 3.2. I'll see you for the next task.